Hello and welcome to another reality check. We're going to be talking about PitotTubes today and their various applications. We're also going to be talking to James Crawford from the Queen's University Department of Mechanical Engineering and also to Adrian Balaj from Fly Kingston. So as you would have learned already from previous online lecture videos, pitot systems measure fluid velocity by comparing the stagnation pressure as measured at the entry to the PitotTube port to a reference static pressure, which could be measured on the side of the port or from a separate location. From this, a pressure differential is taken either by means of a pressure transducer or by a water manometer or some other device, and uses this simple equation here to determine the actual velocity, wherein velocity is calculated by the square root of 2 times the difference in pressure between the two ports divided by the density. Some various applications of pitot systems in real life include open flow measurement, flow measurement through tubes, as well as airspeed measurements from high-speed race cars as well as aircrafts. To learn a little bit more about the various applications and types of pitot systems, we're going to talk to James Crawford.
So we've got a few examples of pitot tubes here. Do you mind talking a little bit about what they're used for and what their specific applications are?
Sure. So fundamentally, pitot tubes are measuring the difference between the total and the static pressure of some flow field. So if we look closely at the probe I have here, there are two important parts. The stagnation port is on the front of it, or is on the tip of the probe, and that's a long tube that runs all the way through this entire apparatus and pokes out the bottom. So we can connect this to a transducer or to some kind of a measuring device to sense the pressure. We also have a ring around the perimeter of the probe here that measures the static pressure of the flow. And that ring feeds into this larger tube, and we can sense the static pressure up here through a second tube down here. So we can hook these to transducers or to water manometers or a lot of different ways to measure pressure once we have it.
I think we have a couple examples, various geometries here of different pitot tubes. You mind just let's go through what applications you can get from these.
Sure. So pitot tubes come in all shapes and sizes. We can put compression fittings on them, so we can install them into the walls of ducts or into pipes. We can stick them out the side of airplanes. So airplanes are an important place that we use pitot tubes. When we put them in an airplane, we'd heat these because they can ice at altitude, so they get fancier than this. Or even as simple as a bent piece of tube is the simplest pitot tube you can make.
And you use it pretty frequently here in the lab, is that correct?
What we do here is we measure and characterize the performance of gas turbine related devices. So things like nacelles that go on the wings of airplanes or exhaust systems that we strap to the exhaust of a gas turbine. So what we might do with a pitot tube is I might put one inside the wind tunnel to measure the free stream velocity of the flow, and I might put another behind a body that we're testing. Say we're measuring the drag of some body, I might put another one behind it and take a full field of measurements. So I might measure here, 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 and we could describe a complete flow field or a complete contour of the wake behind a body.
Right, okay.
Like Jimmy said, one of the most important applications of pitot systems is in aircrafts. So to learn a little bit more about the applications to aviation for pitot systems, I talked to Adrian Balaj with Fly Kingston. So we're going to talk a little bit about pitot probe systems. Can you tell me a little bit about what the system is used for and what measurements you can get with that on an actual airplane?
For sure. So first of all, I'd like to point out the static probe and the pitot probe on an airplane. These two are extremely useful for basically any instrument. I've got here a vertical speed indicator, an altimeter, and a airspeed indicator. Now, the only instrument where both pitot tube and static probes are used is the airspeed indicator. And what they do is that they take the pressure differential and then they give you the airspeed of your airplane. The static probe is used for both vertical speed as well as altimeter. And what these two probes in these three different instruments help you to basically gauge the performance of your airplane while you're flying. Now, you want to make sure that you know your airspeed, you know how fast you're climbing or descending, as well as to how high you may be. If any of these two probes fail, you could find yourself in trouble, given that a low speed would mean a higher stall probability, or a lower altitude would mean that you may find yourself in a dangerous situation.
So is there a lot of historical examples of what might have happened if a pitot-static probe failed?
Right, so a static probe, if it fails, we actually have an alternate one, so you usually can get away with the static probe failing most of the time. However, if your pitot tube fails, given that you don't know your airspeed, there's been quite a bit of accidents. The one that comes to my mind is the Air France accident over the ocean coming in from Brazil. What ended up happening is that all 6 pitot tubes in a big airplane got basically blocked by icing, and then given the low airspeed, what's believed is that the airplane stalled and crashed into the ocean. All right, so we're inside the cockpit right now. I'm going to explain you the 5 basic instruments. Right here we have the attitude indicator, we have the altimeter, which works with the static source, we have our heading, which is basically just a gyros, we have our vertical speed indicator, which works with the static source, and finally the airspeed indicator that works with both pitot tube and static source.
So hopefully you've gained an appreciation for just how valuable a pitot-static system is to the critical operation of a flight. See you next time